All right, class, today we're going to take notes over factoring something called quadratic, We're factoring by using the GCF, or the greatest common factor. On the back, we're gonna factor something that's called difference of two squares. All right, so here are our steps for factoring. These will be written on the board for you, so you'll be able to use them, or they'll be on a sheet on the wall, whatever. But anyway, you'll be able to use these steps not only during class, but on a quiz or a test. So the first thing we're gonna do is find the GCF of all terms. For variables, all the terms must have the variable. That's gonna make sense when we, in fact, let's go ahead and get started, and then I'll refer back to here instead of you having to listen to me read these steps. All right, so this first part right here is just, it's practice. It's kind of a base that we're gonna grow on, all right? So in this column over here, we're looking for the distributed version. And this side over here is the factored version. Well, what does that mean? Well, this side's blank, so we want the distributed version. So we want to take this and distribute this 5x throughout, which most of y'all are pretty good at. Distribute that 5x throughout, and then what would be written right here? Well, what is 5x times x? That would be 5x squared. And then what is 5x times 3? Positive 3. It is a plus 15x. So to go from this side to this side, we're multiplying. Remember that, because it's going to change down here. I've got 2x squared times x. That gives me 2x to the third power. We'll talk about what to do with exponents in class. 2x squared times negative 4 is negative 8x. So if we were multiplying going from this column to this column, we must be dividing going from this column to this column. Now, the trick we're going to use first doesn't always work, but most of the ones we do in this class, let me rephrase that, doesn't always work, but it's going to work for these two right here. The easiest thing to do is to see if the lowest number goes into the higher number. Does 2 go into 4? And it does. All right? So basically, we know that 2 is part of my greatest common factor. And then this side has an x, and that side has an x. So we know x is a part of our greatest common factor. So our GCF on this is going to be 2x. So we're going to divide by 2x. Just like we multiplied by what was outside the parentheses here, that was our GCF. We're going to divide by our GCF over here. So we know that 2x is going to be outside my parentheses. Well, 2 divided by 2 gives me 1. X squared divided by x gives me x. Again, we'll talk about the rules of exponents in class. Negative 4x divided by 2x. Well, negative 4 divided by 2 is negative 2. And then my x's cancel. So I'm finished. Again, on this one, let's try to see if 5 goes into all these. 5 goes into 5. Does 5 go into 15? Yes. If you don't know that, then you'd punch it in your calculator. 15 divided by 5 will give you a whole number. And 5 goes into 30 also. So we know that 5 is a part of my GCF. So I know I'm going to divide by 5. Now let's look at my x's. This term has an x. This term has an x. But this term does not have an x, so x is not a part of my greatest common factor. So 5 is my GCF. Well, what is 15x squared divided by 5? 15 divided by 5 is 3. I don't have anything to divide the x squared by, so it's just x squared. Negative 5 divided by 5 gives me a negative 1x, so I don't have to write the 1. If you want to, it'd be right there. And then 30 divided by 5 is 6. So now on these it gets a little more tricky because the smaller number doesn't always give you the GCF. So on this one, if I did 6 divided by 4, it wouldn't give me a whole number. So we're going to list the factors of the smaller number. What are the factors of the smaller number? Well, 1 times 4, and in class I'm going to show you how to do this part on your calculator. and 2 times 2 gives me 4. So now start with the higher number, or the highest number. Does 4 go into 6? No, not evenly, because if I do 6 divided by 4, it's going to give me a decimal, so it's not 4. Does 2 go into 6? Yes, so we know 2 is part of my GCF. That's what I'm going to divide both terms by. And guys, we're going to get lots of practice on this in class, so don't freak out about if this is hard for you. Now let's look at my letters. This one has an X and that one has a Y. They don't both have an X or they don't both have a Y, so a letter is not a part of my GCF. So I'm going to do 4 divided by 2 is 2. I don't have anything to divide my X by, so it's X. 6 divided by 2 is 3. Don't have anything to divide my Y by, so that is my GCF. Here, let's see, does 6 go into 9? 9 divided by 6 would give you a decimal. 12 divided by 6 will give you a whole number, but it has to go into all of them. So we're going to take the smallest number and list the factors. 1 and 6, and 2 and 3. Again, I'm going to show you how to get the rest of these numbers on your calculator in class. So we know 6 doesn't go into 9, so it's not 6, excuse me. What about 3? Well, 3 goes into 9. I'm going to show you how to check that. 3 goes into 12. So we know 3 is a part of my GCF. Now let's look at my letters. This one has an X. Does that one have an X? Yep. Does that one have an X? Yes. So we know X is a part of my GCF. I know that's what's going to be outside my parentheses. When I have letters in all of them, always look for the lowest exponent one, and that's the one that's going to be the GCF. All right, so we're going to divide everything by 3x. Which 6 divided by 3, it's 2. X to the third divided by x to the first. Again, I'll show you a little trick when we're in class, but that's going to be x squared. Negative 9 divided by 3 is negative 3. X squared divided by x is just x. And then 12 divided by 3 is 4, positive, and my x's cancel. So that's my final answer. All right. So now let's look at this last one. There are no numbers, so we know a number is not going to be a part of my GCF, but they all have y's. So we know y is going to be a part of my GCF. Now find the y that has the lowest exponent, and it's y squared. So that is my GCF. So I'm going to divide everything by y squared. Real quick, what you can do is when you're dividing variables, subtract the exponents. So 8 minus 2 would give you 6, so that would be y to the 6. 5 minus 2 would give you 3, so that'd be minus y to the third. And then anything over itself, so y squared divided by y squared gives you 1, just like 7 divided by 7 is 1, x divided by x is 1, y squared divided by y squared is simply 1. All right, so that's that first sheet. Remember that was factoring by GCF. I'll flip it over. Let me make sure we're straight on the camera. I think we're good. All right, what is the difference of 2 squares? So now we're factoring by dots, difference of 2 squares. They must have 2 perfect squares. We'll talk about that in a sec. They must have subtraction, or the difference. And it can only have 2 terms. All right, so perfect squares, let's talk about those. And you might want to write these off to the side like I'm doing. Perfect squares are numbers times itself. So 1 times 1 is 1. 1 is a perfect square. 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 73, sorry, 9 times, wait, where did I mess up? So 7 times 7 is, 9 times 9 is 81, sorry. And 10 times 10 is 100. Okay, so we'll stop right there. We might have to go higher, but those are all perfect squares through 10 times 10. So first, I like looking for terms too. It has to have two terms. This one only has two terms. It has to have subtraction. It does. And it must be two perfect squares. Well, is 4 a perfect square? Yes. And anytime it's a variable with an even exponent, that is also a perfect square. So let's also write x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th. So it has to be an even exponent. It doesn't have to be x, but the exponent has to be even. So that is the difference of two squares. Let's look at this one. Two terms, meets that one. It's got subtraction, and it's got to be two perfect squares. Well, 16 is on my list. X squared is on my list. So that is the difference of two squares. So now let's figure out how we're going to factor these. Sorry, I lost my train of thought. All right, so anytime I see that it's two terms, subtraction in the middle, and they're two perfect squares, we know my answer is going to look two sets of parentheses, plus between one of them and minus between the other. Now we're going to take the square root of x squared. So basically I'm taking the square root of x squared. What's two things multiplied together? Has to be the same things. That's going to give me x squared. Well, it would be x times x. That is your first term, x and x. And then what is the square root of 1? You can punch that into your calculator. Square root of 1 is 1. So that's going to be your second part of your answer. And that's it, you're finished. You're going to start to like these because you're going to start seeing them and recognizing them really, really quick. Let's do the next one. Got two terms, subtraction between them, perfect square, perfect square. I know my answer is going to look like, look, I generally put the plus first, but it doesn't matter as long as one of them's plus and one of them's minus. Well, we already know what the square root of x squared is. It's x. And then the square root of 100. What is multiplied by itself to give you 100? Well, the answer would be 10. So that's plus 10, and that's minus 10. And that's it, we're done. This one's a little different, but let's go through our steps. It's two terms, check. Subtraction, check. Is 4 a perfect square? Yes. Is x squared a perfect square? Yes. And then 25 is also a perfect square. So we know our answer is going to be two sets of parentheses, plus in one of them, minus in the other. What's the square root of 4? What times itself will give you 4? It's 2. But now you got to do it for that letter too. What times itself will give you x squared? It's x. So that's the first part of my answer. Square root of 25. What times itself gives you 25? You could punch that into your calculator, and it's 5. So that's my next part of my answer. Number 4, trying to trick you. The letter's in the back now, but let's go through our steps. Only has two terms, check. Subtraction, yep. Two perfect squares, 9 on my list. Y squared, remember it doesn't matter what the letter is, look at the exponents. Y squared is a perfect square. What's this? So we know my answer is going to look like that. What's the square root of 9? 3. What's the square root of y squared? Y. So it'd be 3 plus y, 3 minus y. You can always check yourself. In fact, we'll check ourselves at the end when we finish these two. 2x squared minus 8. Let's check. It's got two terms. We're good there. Has subtraction between them. We're good there. Does it have two perfect squares? 2 is not on my list, so it is not the difference of two squares. Let's see if it has a greatest common factor. Does 2 go into 8? Yes, it does. So this is like what we did on the front of the page. Do they both have x? No. So we know 2 is my GCF. I'm going to divide both by 2. Well, 2 divided by 2 gives me 1. That leaves me x squared minus 8 divided by 2 is 4. Okay, so now let's not stop there. Let's go to another step. Let's just look at this part right here. Is that the difference of two squares? Just what's in parentheses. It's got two terms, it's got subtraction, and it's got two perfect squares. So this can be factored again. We know 2 is going to be out front. We're going to have our two sets of parentheses. What's the square root of x squared? It's x. What's the square root of 4? 2. I need a plus between one of them and a minus between the other. So we're done. So we used greatest common factor first, and then we used the difference of two squares. All right, number 6, 27. Not on my list. Well, two terms, subtraction, but 27 is not a perfect square. So let's see if we can use GCF first. Does 3 go into 27? Yes. Did they both have an x? No. So 3 is part of my GCF, and x is not because they don't have x. So we know that's gonna be what my first part looks like. So let's divide everything by 3. 27 divided by 3 is 9, and then x squared. Negative 3 divided by 3 is 1. So now let's look at what's in parentheses. Is 9 a perfect square? Yep. X squared? Yep. 1? Yep. Is there a minus between them? Yep. Don't forget the 3 out front. That's going to be the biggest mistake made on these. You're going to forget to bring this number down. Square root of 9 is 3. I'm going to go ahead and put my plus and minus in there. Square root of x squared is x. Square root of 1 is 1. My other parentheses look identical. So you can always check yourself by doing, by multiplying these two things out. I'm going to use the box method. X times x is x squared. X times 10 is 10x. Oh, I need one of them to be minus. So that would be negative 10x. 10 times x is 10x. 10 times negative 10 is negative 100. Well, look what happens. I've got a positive 10x and a negative 10x. So those two cancel. The only thing I have left is x squared minus 100. And that's what I started with up here. And that's how you can check yourself to make sure that is correct. That's the end of our notes.